Now, this proportional relationship that we have with angles and radians that we can also use within the whole circle, we can use to calculate arc length and sector areas just like with degree measures. And so again, this proportional relationship remains consistent within all of the angles inscribed inside of a circle. So again, think about the central angle and a full rotation. The central angle of a circle divided by 2 pi is going to give us a specific ratio. And let's go back and think about this angle that we had up here, this 30-degree angle, or we could convert it into radians as well. But let's think about if I have 30 degrees out of a 360-degree rotation, what fraction of the rotation of the full circle have we actually rotated? So if we go ahead and we simplify this, we get 1/12. So a 30-degree rotation is 1/12 of a circle. Well, if we rotated 1/12 of the circle, then we've also rotated and created an arc that is 1/12 of the circumference. So the arc that we've made here is 1/12 of the full circumference of the circle. Well, then you can also think about the area of the sector, this pizza wedge. The area of that wedge, the sector, is also going to be 1/12 of the area of the circle. So the ratio of the angle to the rotation is equivalent to the ratio of the arc length to the circumference, which is also equal to the sector's area to the circle's area. And that's what this proportion relationship down here is emphasizing. So again, we can use that proportionality in order to evaluate and answer various questions. So here we're given a circle with a center at O and a central angle AOB that has a measure of 2 pi over 3 radians. Let's go ahead and visualize that circle real quick. So we have an angle of 2 pi over 3. So this angle is 2 pi over 3. The area of the sector that is formed by this angle is what fraction of the area of the circle. So we just want to figure out how much of the rotation compares to a full rotation, which tells us the amount of the sector area related to the full circle area. And so we can look and see with our central angle, if our central angle is 2 pi over 3, and our full rotation is 2 pi, well, then we can just simplify this fraction. Well, to divide 2 pi over 3 by 2 pi, we want to multiply by the reciprocal. And so our 2 pi's will cancel, leaving us with 1/3. So our angle of rotation is 1/3 of a rotation. Our arc length is 1/3 of the circumference. And the area is 1/3 of the circle's area. And that answers this question right here. The area of the sector is 1/3 the area of the circle. Now let's expand on this a little bit. We've answered this question here. It's 1/3. 1/3. But let's think about how we could also use that information. Let's pretend that if we know that our ratio is 1/3, let's pretend that the arc length that we created is, let's say, 27 centimeters. Or actually, let's do 15 centimeters. Okay, so let's say the arc length is 15 centimeters. Well, if our arc length is 1/3 of the full circumference, we could look at the arc length related to the circumference we know the arc length is 1/3 of the circumference. The arc length is actually 15. What we want to do is solve for the actual circumference. We can now find the measure of the circumference based on the arc length and that ratio. Well, a 1-to-3 relationship with 15, using some proportionality, we know that x has to be 45. So the circumference is 45 centimeters. We know the circumference has to be 45 centimeters. Now let's think about a different example. Again, we know that it's a ratio of 1/3, but let's say we know that the area of the circle is 27 centimeters squared. And we want to find the area of the sector. Well, we know the relationship, the sector area compared to the circle area is the same. It's a 1-to-3 relationship. And so we want to find the sector area, but we're given the area of the circle. And so again, by a proportional relationship, if we solve this, 27 equals 3x, x has to equal 9, we know the area of the sector is therefore 9 centimeters squared, which is 1/3 of 27. Using this proportional relationship, we can extend that information beyond to angle measures, to arc length and circumference, and to sector area and circle area.